ImageGenerator class that we used earlier, it actually has the ability to do this for you. Indeed, you have already done a little image augmentation with it when you rescaled upon loading. That saved you from converting all of your images on the file system and then loading them in. You just rescaled on the fly. So let's take a look at some of the other options. And here's how you could use a whole bunch of image augmentation options with the image generator adding on to rescale. Rotation range is a range from 0 to 180 degrees with which to randomly rotate images. So in this case, the image will rotate by a random amount between 0 and 40 degrees. Shifting moves the image around inside its frame. Many pictures have the subject centered, so if we train based on those kind of images, we might overfit for that scenario. These parameters specify as a proportion of the image size how much we should randomly move the subject around. So in this case, we might offset it by 20% vertically or horizontally. Shearing is also quite powerful. So for example, consider the image on the right. We know that it's a person, but in our training set, we don't have any images of a person in that orientation. However, we do have an image like this one, where the person is oriented similarly. So if we shear that person by skewing along the x-axis, we'll end up in a similar pose. And that's what the shear range parameter gives us. It will shear the image by random amounts up to the specified portion in the image. So in this case, it will shear up to 20% of the image. Zoom can also be very effective. For example, consider the image on the right. It's obviously a woman facing to the right. Our image on the left is from the humans or horses training set, and it's very similar, but it's zoomed out to see the full person. If we zoom in on the training image, we could end up with a very similar image to the one on the right. Thus, if we zoom while training, we could spot more generalized examples like this one. So you zoom with code like this. The 0.2 is the relative portion of the image you will zoom in on. So in this case, zooms will be a random amount up to 20% of the size of the image. Another useful tool is horizontal flipping. So for example, if you consider the picture on the right, we might not be able to classify it correctly as our training data doesn't have the image of a woman with her left hand raised. It does have the image on the left where the subject's right arm is raised. So if the image were flipped horizontally, then it becomes more structurally similar to the image on the right, and we might not overfit to right arm raisers. To turn on random horizontal flipping, you just say horizontal flip equals true, and the images will be flipped at random. Finally, we just specify the fill mode, and this fills in any pixels that might have been lost by the operations. I'm just going to stick with nearest here, which uses neighbors of that pixel to try and keep uniformity. Check the Keras documentation for some other options. So that's the concept of image augmentation. Let's now take a look at cats versus dogs that are trained with and without augmentation so that we can see the impact.
Listen to my